Other components then is this power shaft, and then I use some aluminum tubing that I cut several little pieces to act as bushing. And then when you put your power reel, is the next thing to go on the shaft with the bearing on either side. It ends up just perfect where it hits and you can spin. Okay, so what this is then, is you use your aluminum, it's 7/32 stock aluminum, and then I use some brass rod, some 3/16 inch brass rod, so that basically these will go inside of each other. So you kind of use that quite a bit for bushings and stuff. So I'll cut pieces of those two, the aluminum and the brass, polish them up, and then so you cut your aluminum spacer basically and put that on the top part, and then you put your wheel on, and that goes through, but there's quite a bit of play. So then you have a bushing. This basically it's the brass shaft with a little bit of a that aluminum super glued in place, because what you want to do is be able to run that through then, and basically that forms your shaft that can go up and down, and it spins real well. And then that upper spreader there keeps it from going all the way up and hitting the top of the bolt, and then the bottom one here keeps it from coming down too far, so it just limits your play of being able to do your vertical alignment on there. And it's real important for friction. If these get a top or bottom, you don't want anything rubbing on the bearing. You want these to be really smooth running, even if they're torqued or high, a lot of force on them. So you want to kind of watch that when you're building this thing to make sure there's no areas that can bind. Okay, then on the bottom here you end up leaving a little bit of space for that bushing or the brass, and then you put on your Boca bearing. This is a flange bearing, by the way, because you want the flange to be able to capture the top of this reel. And then you put the reel on like that. So now you've got it basically in place, as you can see here, but the bottom is real flimsy. So then you put on your bottom bearing. So now the traction wheel and the power reel both have bearings on top and bottom of them. And then you slide in one more little bushing here that's basically a piece of brass with the aluminum, and that goes on like that. So now you have a pretty nice system here that will slide back and forth for the top, and then you can see where that engages the you can see where it engages the reel to be able to spin. Okay, then a key component here then of the next alignment phase is to get this all tightened up so that you can mount it. So I use just a single bolt or a single nut and wind that on there, so it's basically just tight enough so that it takes out all the play, and you can't really do too much spinning like that. And you tighten it up just enough so that it's finger tight, and then the thing will spin real well, because it's going to get a little bit tighter when you hook it onto the frame. So then the next step is to attach it to the frame, which is just through a pre-drilled hole in the frame. This is a piece of fiberglass or G10 that extends off the side of the carbon fiber frame. And then basically what I did was actually I rig it with a single washer and then run it through, put another washer on it and a lock washer, and then a wing nut so that you can take it apart in the field if you need to change the reels out. And tighten her up. Basically hand tighten it to get her to lock pretty good. And then by that time you want to basically have it so that it runs pretty smooth and there's no real play either side of your line, so there's not a lot of play in it, and then you're good. Okay. And if you look at the alignment on this guy, if you can see it, you're basically coming straight down right across the tangent of that inside gap of the convex of the thing. Then the other thing that's really important is the vertical alignment of the rigging pulleys. So if you look here, you want the line basically from the bottom of this rigging pulley on either side, the very where the line comes through. You want that to come just through the center line of the lowest point of that curve. And actually the way you want to do it, this line that I use is, I think it's 150 or 200 pound test, is about 50 thousandths. So I rigged this side up to be about 150 thousandths above the center line, roughly just barely above, and then the bottom one is about 50 thousandths below, so that basically when this thing comes through here, one of the places that can get you in trouble with friction is between these two lines. When they come together, you want to spread them apart just enough so that they're coming, one side's coming in on the top, the other side's exiting on the bottom. But if you spread them apart too far by rigging this side up too high and this one down too low, what you'll end up doing is putting torque on this traction wheel when the tension gets real high, and then what that'll do is actually bend it and distort it and cause it to misalign, and then you got problems with friction. So you really want to keep these guys coming in and going out as close to the center line, the deepest point of that cup or that convex. This guy comes in just above the center line, comes around and exits just on or below the center line. And you can mess around with that. And then as things tighten up or move around, you've got that alignment so that this can kind of self-seat itself. So there's kind of a self-alignment function built into it. But you kind of want to get these rigged just right. Otherwise, again, these two lines, when they're coming around, they'll rub against each other, and you got friction. And when it gets real tight, basically the thing will just stop and it won't come down on its own. So you want to, there's a real interesting kind of a fine tuning to get that just right. You want to kind of run it up and down and feel for areas of friction, feel for things that might be binding. It should be very smooth all the way, up and down. Okay, it's coming back down now. Okay, good.